Okay, so for the electric field due to two thin rods problem, we have calculated the electric field due to the second rod in the location of the first rod. Then we calculated the net force acting on the first rod. Now in part C, show that if A is much greater than L, what is A? This distance between the two rods is much greater than L, so they're really far away. The magnitude of this force reduces to Q square over 4 pi epsilon 0 A square. So it's asking us to use the Taylor series expansion of natural logarithm of 1 plus z valid for absolute value of z much less than 1 and carry all the expansions to at least order L squared over A squared. And then interpret this result. Okay, so let's see what happens when A is much greater than L. The two rods are really far away. The force, remember, is Q squared over 4 pi epsilon 0 L squared natural logarithm. So let's copy this force here. Now it is A plus L parentheses squared. So let's take the A out. So it is A plus, so if I take the A out here, it will come out as A square. So this will be A square 1 plus L over A parentheses squared. And then I have an A underneath, and there's another A here, so I can take that A out. So I will have A squared 1 plus 2L over A parentheses squared inside the natural logarithm. And you can see that these A squareds will cancel, and this force is in I hat direction. So this can be written as Q squared over 4 pi epsilon 0 L squared 2 times natural logarithm 1 plus L over A minus natural logarithm minus natural logarithm. There is no square here, right? So there is no square. Natural logarithm 1 plus 2L over A. All right, so that's basically this term here with the A parentheses. So, and that force is in I hat direction. Now, natural logarithm of 1 plus L over A. This is basically natural logarithm of 1 plus z, and we are looking at the limit z becoming much less than 1 here. So L over A is much less than 1, which means A is much greater than L. So that's this limit. The Taylor series expansion gives me, first you have to evaluate that z equals 0. You get the first term, natural logarithm of 1. Then we take a derivative plus 1 over 1 plus z evaluated at z is equal to 0 multiplied by z minus 0, which is z. Then we take the second derivative minus 1 over 1 plus z parentheses squared. We also have a 2 factorial 1 plus z parentheses squared evaluated at z is equal to 0 multiplied by z squared. Then we have another derivative which is going to give us 2 over 3 factorial 1 plus z cube parentheses cube z is equal to 0 z cube, and then we have higher order terms. So you can see that this gives us natural logarithm 1 is 0. 1 over 1 plus z becomes 1. So the first term is z. The second term is 1 over 2 z squared with a minus sign. So minus z squared over 2. The third term is, because this is 3 factorial, which is 3 times 2, 2's will cancel, 1 over 3. So it's going to be plus z cubed over 3 plus higher order terms. Okay, so using this expansion for the force in the limit a much greater than L, we find approximately q squared over 4 pi epsilon 0 L squared. Now, instead of 2 times natural logarithm 1 plus a, I have 2 times L over a minus 2 times L square over a square over 2. So it's L square over a square. So I'm substituting for z L over a. And then I have plus 2 times L cube over 3a cube. And then for this term, now z is equal to 2L over a. I have the first term z, which is 2L over a. So I have minus 2L over a. Then I have the second term minus z squared over 2, which is minus 4L squared over a squared. But with this minus sign here, it becomes plus. So plus 4L squared over a squared, but there is a 1/2 here. So 2a squared. Then I have plus z cubed over 3, which is 8L cubed over 3a cubed. And it's going to be with the minus sign, because this is plus, that's minus. So that's going to be minus 8L cubed over 3a cubed and higher order terms. Okay, so I can see that 2L over a's are canceling out. And I'm neglecting the third order terms, L cubed over a cubed. I'm taking it to be approximately equal to 0. So this is approximately equal to 0. And I'm only considering the second order terms then, which are 4L squared over 2a squared minus L squared over a squared. So what does that give me? That gives me the force F for a much greater than L, approximately q squared over 4 pi epsilon 0 L squared. Then I have 2L squared over a squared minus L squared over a squared. So L squared over a squared in I hat direction. And L squares will cancel. And therefore, I will find the total force to be F is equal to q squared over 4 pi epsilon 0 a squared in I hat direction. Now we have to interpret this result. When the rods are too far away from each other, a is much greater than L, they will look like points to each other. So they're really far away, they will look like points. It turns into the interaction between 2 point charges, so they behave as point charges when they are too far away. So that's the interpretation of this result. So what we have done here is we have taken the answer in part B and looked at the limit a is much greater than L. In order to do that, we have taken this into a parenthesis, this into a parenthesis, obtained L over A and 2L over A ratios, and we have used this Taylor series expansion, which was given as a hint in the problem statement, but we have rederived it using Taylor series. And then we see that in that limit, we obtain, for when we keep the second order terms, but not the third order terms and higher order terms, we obtain the force due to 2-point charges. And that makes sense because when the rods are too far away, they will look like point charges to each other.